Bright Duty. Every student matters.
Students, previously we discussed how do we know that a reaction has occurred. For that, we studied the features that tell if a reaction has occurred. Then we understood what is a chemical equation and what are the different types of chemical reaction. But there are two specific types of reaction which are very useful in the study of chemistry and biology as well. They are oxidation and reduction reaction. They do not fall part of the classical division that we studied before, but they are very useful, so we are also studying them separately. First is oxidation reaction. Oxidation reaction is when a substance either gains oxygen or loses hydrogen. Both of the cases are called as oxidation reaction. So if copper gains oxygen and forms copper oxide, then it is called as oxidation reaction. You have this in your syllabus as an activity that copper gets a deposit of black layer over it. That black layer is actually copper oxide, which it forms by reacting with the air, oxygen present in the air.
Take a hard glass tube about 50 centimeters long, 4 centimeter in diameter and open at both ends. Once we have this hard glass tube, we will place it with help of in a horizontal position with help of the iron clamp stand. Place the 2 grams of copper powder, reddish brown in color, in a small watch glass and then introduce it inside the glass tube. Close the both ends of the glass tube with rubber stoppers in which we insert the glass tubings. Heat the watch glass strongly for a few minutes. Slowly blow in air and record your observations about 10 minutes. You observe that the reddish brown color of copper will slowly change to black color. This black substance is copper oxide, which is formed when oxygen is added to the copper. So what you will see is it starts happening at the surface layer and then starts happening in the layers below it. The copper reacts with oxygen that you blow in through the air and it combines to form CuO, which is copper oxide. This is a classic example of oxidation reaction. The reddish brown color of copper is lost and a new black color is obtained. In this reaction, as oxygen is added to copper, it is therefore an oxidation reaction. Now go on heating the glass tube and pass hydrogen over the black copper oxide for about 10 minutes or more. Then make your observations again. What we will see on passing hydrogen gas is that the black color of copper oxide slowly regains its original reddish brown color. So as you must have guessed that copper oxide in the presence of hydrogen loses the oxygen and again forms copper and water. The hydrogen gets removed in the water and thus it shows that this is an example of a reaction where copper oxide is slowly losing its oxygen. In this reaction, copper oxide is in fact reduced to copper, and that is why, because of the loss of oxygen, this is an example of reduction reaction. So we saw both oxidation and reduction reaction happening in this activity.
Similarly, sodium can also react with oxygen, forming sodium oxide, and this sodium oxide is basically sodium which is now oxidized to form sodium oxide. The opposite of oxidation is reduction. When a substance either loses oxygen or gains hydrogen, then it is called as reduction. For example, when hydrogen reacts with chlorine, the chlorine gets reduced because it has gained a hydrogen atom. So here hydrogen is gained and oxygen is lost in reduction. Whereas in oxidation, oxygen is gained and hydrogen is lost. That is how you need to remember these reactions. Now in nature, most of the times these two reactions occur together. When they occur together, when we add reduction and oxidation, we get redox reaction. It is called as redox reaction, but which is a short form for reduction and oxidation reaction. What happens in redox reaction is that one substance is getting oxidized, is either gaining oxygen or losing hydrogen, whereas another substance is getting reduced, that is gaining hydrogen or losing oxygen. So let us take this one example of redox reaction. Copper oxide reacts with hydrogen in presence of heat to form copper and water. Here the copper initially had an oxygen and now it has lost it. That means it has got reduced. This is reduction. Hydrogen initially had no oxygen but now it has gained. That means this is oxidation. When both reduction and oxidation are occurring in the same chemical equation, then that reaction is called as a redox reaction. We are studying this separately because it is very important part of the day-to-day life. Redox reaction is there in the photosynthesis by which plants are producing food. It is there in the laptop batteries or the computer batteries that you're using right now, and it is even there in basic things like fire. So all of them are occurring based on a redox reaction similar to this type, where one substance gets reduced, another gets oxidized. Let's take another example here. This is manganese oxide and this is hydrochloric acid. So manganese initially had oxygen and now it has lost the oxygen, which means it has been reduced. Now HCl initially, so chlorine, because we will not consider hydrogen to be an element that is getting reduced or lost. So chlorine here had an hydrogen but now it has lost the hydrogen. So it got oxidized. Now oxidation or reduction do not occur on their own. They often need an agent to help it happen. So the substance which gets oxidized, like here copper oxide got reduced, or here hydrogen got oxidized. For both of them they need another agent. So hydrogen got oxidized to form water because of the agent copper oxide, which works as an oxidizing agent. The agent is that component which is not participating but getting reduced. The element which is reduced is oxidizing agent. The element which is oxidized is reducing agent. Let us just study it here to get a clearer picture. So the substance which is oxidized here is H2. The substance which is reduced is copper oxide. So now what will be the oxidizing agent? Oxidizing agent will be the same substance which got reduced, that is copper oxide, because it helped in this oxidation process. It was the one which gave this oxygen, that is why it is called as oxidizing agent. Now reducing agent. What will be the reducing agent? H2 will be the reducing agent, because H2 was what took the oxygen from copper, which made it reduce. So that is how we identify the oxidizing agent and the reducing agent. Oxidizing agent is that substance which leads to the oxidation of another substance by getting reduced itself. Reducing agent is that substance which leads to the reduction of other substance by getting oxidized. Let us try this for this equation as well. Here, what is being reduced? The substance which is reduced is manganese oxide. Substance which is oxidized is hydrochloric acid. Now, what is the oxidizing agent? Oxidizing agent is that which gets reduced. So what is being reduced? MnO2. And what is the reducing agent which gets oxidized? What substance got oxidized? HCl. So as you can see, this is how this type of questions are very common. In exam, they will give you an equation like this and you will be asked to identify what is the substance that got oxidized, what is the substance that got reduced, what was the oxidizing agent and what was the reducing agent. If you are able to identify these two, you can do this easily, as the substance which is reduced becomes the oxidizing agent and the substance which is oxidized becomes the reducing agent. Here you can also see, to be able to identify these, you just need to know which is the substance that is either gaining oxygen or losing hydrogen. That will be the substance which is being oxidized. To know what is the substance that is being reduced, you have to identify a substance which is either losing oxygen or it is gaining hydrogen. That is the summary for the redox reaction that occur commonly in nature. Now, based on these reactions, all the reactions that we have studied so far, there are some practical problems that can be understood, and their prevention can also be understood by you now as you have gained the knowledge of chemical reactions.